Okay, so this is a key to topic 21, part C, and this is the worksheet called Extra 10. And in these, you want to add and subtract radicals. And remember, though, that in order to add or subtract radicals, they have to be like terms. All right, so you can only add or subtract like terms. Now, the situation here is that you're going to have to simplify the radicals first. So in each of these cases, in almost all of the problems on this worksheet, you have to simplify first and then combine like terms. So let's look at number one. So number one, and by the way, it does say show work, so you must show the work. All right, one, you have x square root of 2x plus 2 square root of 18x to the third power plus 7x square root of 18x. All right, now almost all of these problems will involve uh, um, lessons and experiences from previous lessons. So so remember you have to remember how to simplify radicals. Okay, so in the first one, see there are three terms here. In the first one, the square root of 2x, you cannot simplify the square root of 2, and you cannot simplify the square root of x because the exponent of 1 is less than the index. All right, so I can't do anything with this. But let's look at this right here. So I'm going to go off to the side. I'm actually going to do the work on that one. All right, so let's talk about the square root of 18x cubed. All right, so from previous lessons, we know that I can write this as a square root of 18 times the square root of x cubed. All right, and I know that I can simplify the square root of 18 because the largest perfect square that goes in 18 is 9. So I can write this as the square root of 9 times the square root of 2. And I know I can simplify the square root of x cubed because the exponent 3 is greater than or equal to the index, which is 2. And remember, 3 is not divisible by 2, so I want to figure out, well, what is the largest whole number less than 3 that's divisible by 2? And so that's going to be 2. So I get the square root of x squared times the square root of x. All right? And it makes sense because when you multiply like bases, you add exponents. 2 plus 1 is 3. So now I have four factors here. So let's go ahead and simplify each of those if I can. I can simplify the square root of 9. That's 3. I cannot simplify the square root of 2. I can simplify the square root of x squared, that's x. I cannot simplify the square root of x. But we also know, that's a 3 here, we also know that I can rewrite the square root of 2 times the square root of x as one square root using the product property. So it'll be 3x, put the factors in front that don't involve radicals and put the radicals at the end. So it'll be 3x square root of 2x. All right, so that is this, which is this part here. So I get x square root of 2x plus 2 times this. Now remember, this is this. So rewrite it. 3x square root of 2x plus 7 times, all right, now let's talk about this. 7x rather. 7x times, and let's simplify the square root of x, 18x. All right, so I'm going to put that right here. So the square root of 18x, I know I can write using a product rule as square root of 18 times the square root of x. The largest perfect square that goes in 18 is 9, so I can rewrite this as the square root of 9 times the square root of 2 times the square root of x. And so the square root of 9 is 3, so I get 3. And then I can write this as one square root, so 3 square root of 2x. So that part goes here. So that's this. So times 3 square root of 2x. Okay? All right, now let's kind of simplify each of those three terms further if we can. I cannot do anything else with this first term, so I'm going to rewrite it. I can multiply 2 and 3 together, so I'm going to rewrite it as 6x square root of 2x. And I can multiply 7 and 3, so I'm going to write this as 21x square root of 2x. And now notice all of these terms, all of those terms are like terms. Okay, all of them are like terms. So I have 1 here, so that's a 1. I have 1 here. I have 6 here, and I have 21 here. So altogether, then I have 1 plus 6 is 7. 7 plus 21 is 28. So I get 28x square root of 2x. All right, so that's number 1. Okay. Number 2, here's what we have for number 2. Number 2, we have 6 6 square root of x cubed minus x square root of 4x. All right, so I have two terms. Let's talk about this one first. Let's see if I can simplify the square root of x cubed. So let's do the work here. So the square root of x cubed, from previous experiences, previous lessons, we know I can write this as the square root of x squared times the square root of x. And the square root of x squared is x, because x times x is x squared, right? So I get x squared of x. So that part is this. So this becomes 6 times x squared of x. Okay? Now let's talk about the square root of 4x. Square root of 4x. Well, I know that the square root of 4x I can write as a square root of 4 times the square root of x using a product property that we've learned previously. And I know that the square root of 4 is 2, so I get 2 square root of x. So that is just square root of 4x. So that becomes minus x times 2 square root of x. Okay? So then let's go ahead and rewrite this. So I'm just going to rewrite as 6x squared of x minus, I'm going to put the 2 in front, so 2x squared of x. And I want you to notice those are like terms. Those are like terms now. So I have 6x squared of x and then minus 2x squared of x. Those are like terms. So 6 and a negative 2 is a positive 4. So I get 4x squared of x. So there's the answer there. Okay, so that was number 2. Number 3, all right, so here's number 3. All right, number 3, you have 2 square root of 3x plus 6 square root of 48x plus 6 square root of 75x. All right, and so there are 3 terms. I have 3 radicals that I see. So let's simplify each one of those. Now, first of all, you need to notice that you cannot do anything else with square root of 3x. That's as simplified as you can get. The only perfect square that goes into 3 is 1, and the exponent of x is 1. 1's less than 2. In the second one, if you look at the square root of 48x, I know I can simplify the square root of 48. And so let's go ahead and use the product rule here. So it'll be the square root of 48 times the square root of x. The largest perfect square that goes into 48 is 16. So I can write this as the square root of 16 times the square root of 3 times the square root of x. Okay? And then the square root of 16 is 4. And I'm going to rewrite this as square root of 3x using a product property. So remember, when the indices are the same, you can multiply the radicands. So that is the square root of 48x. So I'm going to put that here. So I get 2 square root of 3x plus 6 times 4 square root of 3x. See, that's this right here, right? And then let's talk about the square root of 75x. All right, square root of 75x, I can write as square root of 75 times the square root of x. Okay? And the square root of 75, the largest perfect square that goes into 75 is 25. So we square root of 25 times the square root of 3 times the square root of x. And so the square root of 25 is 5. So I get 5. And again, I can write this as 1 square root. So it'll be square root of 3x. So that's this. So this becomes 6 times 5 square root of 3x. All right, let's simplify each of those further. So this stays 2 square root of 3x. Here I can multiply 6 and 4 together, so that becomes 24 square root of 3x. And 6 times 5 times the square root of 3x is equivalent to saying 30 square root of 3x. And again, notice that all those terms are alike. All the indices are the same. They're all square roots, and the radicands are the same. Okay? So 2 plus 24 is 26. 26 plus 30 is, what's that, 56? So you get 56 square root of 3x. All right, so that was number 3. Number 4, you have 6 square root of 175x minus 6 square root of 28x. All right, and so you have 2 terms. We have to simplify before we can combine. So let's talk about the square root of 175x. So let's talk about that. So the square root of 175x, by using the product property, product rule, I know I can write this square root of 175 times the square root of x. The largest perfect square that goes into 175 looks like is 25, right? Okay, so I get the square root of 25 times the square root of, let's see, 25 times 4 is 100. 25 times 5 is 100, 125. And so 25 times, I think it's what, 7? Okay, so 7, right, is 175. And then times the square root of x. And so then we get the square root of 25 is 5, and then square root of 7 to the square root of x using the product property. Since the indices are the same, I can multiply the radicands. That's the square root of 7x. So this goes here now, okay? So it'll be 6 times 5 square root of 7x minus 6 times, all right, let's talk about the square root of 28x. So the square root of 28x, let's see, all right, square root of 28x, I know I can write as a square root of 28 times the square root of x. The largest perfect square that goes into 28 is 4. So I get the square root of 4 times the square root of 7. So that's square root of 28. 4 times 7 is 28 times the square root of x. All right, so I have those three factors multiplied together. I can simplify the square root of 4. That's 2. I cannot simplify anything else, but I do know that I can write this as one square root because they're both square roots, and so therefore they both have the same index, and so I can multiply the radicands together. So I have the square root of 7x. So that goes here. So that's 2 square root of 7x. And now I can rewrite this further because I know that 6 times 5 is 30. So I get 30 square root of 7x minus 12 square root of 7x. Those are like terms. They both contain square root of 7x. 30 and a negative 12 is a positive 18. So positive 18 square root of 7x. All right. Okay, and then let's do number 5. So number 5 is the last one. Number 5, we have this. Number 5, we have the square root of 20x to the 5th minus x times the square root of 5x to the 3rd plus 2 times the square root of 125 x to the 5th. Okay, so again, I have 3 terms, but I've got to simplify each of those radicals that I see before I can combine anything. So let's do the first one. So the first one is the square root of 20 x to the 5th. I know by the product property I can rewrite this as the square root of 20 times the square root of x to the 5th. All right, so we're going to talk about simplifying each of those. So the largest perfect square that goes into 20 is 4, so I can write this as the square root of 4 times the square root of 5. 4 times 5 is 20. I can simplify this because I know that the exponent of 5 is greater than or equal to 2. The index here is 2. But it's not divisible by 2. So think of the largest whole number less than 5 that's divisible by 2, and that's 4. So it becomes the square root of x to the 4th times the square root of x, because 4 plus 1 is 5. And so now I have 4 of these factors. I can simplify this one. Square root of 4 is 2. I cannot simplify the square root of 5. I can simplify the square root of x to the 4th. The square root of x to the 4th is x squared because x squared times itself is x to the 4th. I cannot simplify the square root of x, so the exponent of 1 is less than 2. But I do know I can rewrite this product of those two square roots as 1. So it has become 2x squared, and always put the radical at the end, 5x, square root of 5x. All right, so that is this. So that becomes 2x squared square root of 5x. Okay? Now let's talk about this one now, the square root of 5x cubed. So let's talk about that. Okay, let's do that here. The square root of 5x cubed. By the product property, I know I can rewrite the square root of 5 times the square root of x cubed. I cannot simplify the square root of 5 because the only perfect square that goes into 5 is 1. But I can simplify the square root of x cubed because the exponent of 3 is greater than or equal to 2. And although 3 is not divisible by 2, I know how to handle that. The largest whole number less than 3 that is divisible by 2 is 2. So I get the square root of 5 times the square root of x squared times the square root of x. 2 plus 1 is 3. When you multiply like bases, you add exponents. And so the only one of these I can simplify is this. So this becomes the square root of 5 times x, because x times x squared, times the square root of x. And I'm going to write this as one radical. So I get x square root of 5x. So that part, which is this, becomes this. So that becomes minus x times, now remember this right here we just found. We found it to be x square root of 5x. Okay? Now let's talk about this one. Now I'm going to go ahead and do that one around here. So let's just kind of do that here. So I have the square root of 125 x to the fifth. According to the product rule, I can write this as the square root of 125 times the square root of x to the fifth, right? And the largest perfect square that goes into 125 is 25. So I get the square root of 25 times the square root of 3. I'm sorry, square root of 5, excuse me, square root of 5. And I can simplify the square root of x to the fifth because 5 is greater than or equal to 2. But although 5 is not divisible by 2, I know I can still deal with it. The largest whole number less than 5 that's divisible by 2 is 4. So it becomes the square root of x to the fourth times the square root of x. 4 plus 1 is 5. And then notice I have 4 factors. I can simplify this one. Square root of 5 is 5. I cannot simplify this. Square root of 5, leave it as square root of 5. I can simplify the square root of x to the fourth. 4 divided by 2 is 2. So 4 divided by the index is 2. So I know this will be x squared because x squared times x squared is x to the fourth. And I cannot simplify the square root of x. But I do know I can rewrite this as 1 square root and put the other factors in front. So I get 5x squared square root of 5x. So that part here is this. So it becomes plus 2 times 5x squared square root of 5x. Now, let's simplify them further. So I have 2x squared square root of 5x. I know that x times x is x squared, so I get minus x squared square root of 5x. And I know that 2 times 5 is 10, so I get plus 10x squared square root of 5x. All right. Now I want you to notice, and this is important that you see this. I want you to notice that all 3 terms are like terms. They all have the square root of 5x. In addition to that, you see some of the variables. You have x squared, you have x squared, and you have x squared. So that makes them all like terms. And all you have to do now is just combine their coefficients. So 2x squared square root of 5x minus 1x squared square root of 5x, that's 1. 2 and a negative 1 is 1. 1x squared square root of 5x, and 10 of them gives me 11. So the answer is 11x squared square root of 5x. Okay? All right, so that is the key to the worksheet on topic 21, radicals extra 10.